Martians. Why so many speculations and fantasies about Martians, rather than Saturnians, say, or Plutonians? Because Mars seems at first glance very Earth-like. It's the nearest planet whose surface we can see. There are polar ice caps, drifting white clouds, raging dust storms, seasonally changing patterns, even a 24-hour day. It's tempting to think of it as an inhabited world. Mars has become a kind of mythic arena onto which we've projected our earthly hopes and fears. The most tantalizing myths about Mars have proved wrong. So a few people have swung to the opposite extreme and concluded that the planet is of little interest. They've begun to sing blues for the red planet. But the real Mars is a world of wonders. Its future prospects are far more intriguing than our past apprehensions about it. In our time, we have sifted the sands of Mars, established a presence there, and fulfilled a century of dreams. The most startling dream of Mars was that of H.G. Wells, who in 1897 wrote The War of the Worlds.
No one would have believed in the last years of the 19th century that this world was being watched keenly and closely by intelligences greater than man's, and yet as mortal as his own. As men busied themselves about their various concerns, they were scrutinized and studied, perhaps almost as narrowly as a man with a microscope might scrutinize the transient creatures that swarm and multiply in a drop of water. With infinite complacency, men went to and fro over this globe about their little affairs, serene in their assurance of their empire over matter. It's possible that the infusoria under the microscope do the same. No one gave a thought to the older worlds of space as sources of human danger, or thought of them only to dismiss the idea of life upon them as impossible or improbable. It is curious to recall some of the mental habits of those departed days. At most, terrestrial men fancied there might be other men upon Mars, perhaps inferior to themselves, and ready to welcome a missionary enterprise. Yet, across the gulf of space, intellects vast and cool and unsympathetic regarded this Earth with envious eyes, and slowly and surely drew their plans against us.
Wells's novel captured the popular imagination in the late Victorian era. This was a time when the automobile was a novelty. when the pace of life was still largely determined by the speed of the horse. Into this world, Wells introduced an interplanetary fantasy with spaceships, ray guns, and implacable aliens. These were original and disquieting possibilities. The Martians of H.G. Wells were not merely minor variations on a human theme. Instead, they were the evolutionary product of a totally alien environment. "40 years later, this fantasy was still able to frighten millions in war-jittery America when it was dramatized for radio by the young Orson Welles. A few years before The War of the Worlds was published, another and quite different vision of Martians was forming in the mind of a wealthy Bostonian named Percival Lowell. The Martians of H.G. Wells were a way for the novelist to examine contemporary society through alien eyes. But the Martians of Percival Lowell were, he believed, very real. It was here that the most elaborate claims in support of life on Mars were developed. Lowell dabbled in astronomy as a young man. He went off to Harvard. He had a semi-official diplomatic appointment to Korea, and otherwise engaged in the usual pursuits of the wealthy for his time. But his lifelong love was the planet Mars. Lowell was electrified by the announcement in 1877 by an Italian astronomer, Giovanni Schiaparelli, of canali on Mars. Schiaparelli had reported during a close approach of Mars to the Earth an intricate network of single and double straight lines crisscrossing the bright areas of Mars. Now, canali in Italian means channels or grooves, but it was promptly translated into English as canals, a word which understandably has a certain implication of intelligent design. A Mars mania swept through Europe and America, and Percival Lowell found himself caught up in it. In 1892, his eyesight failing, Schiaparelli announced he was giving up observing Mars. Lowell resolved to continue the work. He wanted a first-rate observing site, undisturbed by clouds or city lights, and marked by good seeing. Seeing is the astronomer's term for a steady atmosphere through which the shimmering of an astronomical image in the telescope is minimized. Lowell built his observatory far away from home on Mars Hill, here in Flagstaff, Arizona. Lowell sketched the surface features of Mars, and particularly the canals, which mesmerized him. Now, observations of this sort aren't easy. You put in long hours at the telescope in the chill of the early morning. Most of the time, the seeing is crummy. When the seeing is bad, the image of Mars blurs and distorts, and you have to ignore what you've observed. But occasionally, the image steadies, and the features of the planet marvelously flash out at you. You must then remember what you've seen and accurately commit it to paper. You must put your preconceptions aside and with an open mind set down the wonders that Mars holds in store for us. This is Percival Lowell's own notebook. Here's what he thought he saw. Bright and dark areas, a hint of a polar cap, and canals. Lots and lots of canals. Lowell believed that he was seeing a globe-girdling network of great irrigation canals carrying water from the melting polar caps to the thirsty inhabitants of the equatorial cities. He believed the planet was inhabited by an older and wiser race, perhaps very different from us. He believed that the seasonal changes in the dark areas were due to the growth and decay of vegetation. He believed that the planet was Earth-like. All in all, he believed too much. Lowell's Martians were a dying race. Their once great cities had fallen into ruins. Lowell believed that the Martian climate was changing, that the precious water was trickling away into space, that the planet was becoming a desert world. The canals, he thought, were a last desperate measure, a heroic engineering effort to conserve the scarce water. But their technology, although far more advanced than ours, was inadequate to stem a planetary catastrophe. The most serious contemporary challenge to Lowell's ideas came from an unlikely source, the biologist Alfred Russel Wallace, co-discoverer of evolution by natural selection. Wallace correctly showed that the air on Mars was much too cold and thin to permit the existence of liquid water. He wrote that only a race of madmen would build canals under such conditions. Lowell's Martians were benign and hopeful, even a little godlike. Very different from the malevolent menace posed by H.G. Wells and Orson Welles in The War of the Worlds. Both sets of ideas passed into the public imagination through Sunday supplements and science fiction, and excited generations of 8-year-olds into fantasizing that they themselves might one day voyage to the distant planet Mars. I remember reading with breathless fascination the Mars novels of Edgar Rice Burroughs. I journeyed with John Carter, gentleman adventurer from Virginia, to Barsoom, as Mars was known by its inhabitants. Wandering among the beasts of burden called thoats, winning the hand of the lovely Deja Thoris, princess of helium, and befriending a 10-foot-high green fighting man named Tars Tarkas as the moons of Mars hurtled overhead on a summer's evening on Barsoom. It aroused generations of 8-year-olds myself among them, to consider the exploration of the planets as a real possibility, to wonder whether we ourselves might one day venture to the distant planet Mars. John Carter got to Barsoom by standing in an open field, spreading his hands and wishing hard at Mars. I can remember spending many an hour in my boyhood, arms resolutely outstretched in an open field in twilight, imploring what I believed to be Mars to transport me there. It never worked. There had to be some better way. And there was. The real road to Mars was opened by a boy who loved skyrockets. Fourth of July celebrations in New England are much the same today as they were in the 1890s. Then, as now, the highlight of the day's festivities was a rousing fireworks display. That was the part that Robert Goddard liked the best. By the time he was 16, he was launching his own rockets. He wrote in his diary, July 4th, 1898, fired cannon and firecrackers all day. In evening, had 5 rockets.
Light it now? Wow!
That same year, The War of the Worlds was being serialized in the Boston Post. Goddard eagerly read every word. The Boston newspapers were also reporting intriguing conjectures by a Professor Lowell, whose lectures Goddard would later attend. The images of Mars spun by Wells and Lowell beguiled the young Goddard. And at age 17, on October 19th, 1899, they crystallized into an overwhelming vision that provided the direction and purpose of his life. From the high branches of an old cherry tree on his family's farm, Goddard saw a way to do more than just speculate about Mars. Before anyone had ever flown in an airplane or listened to a radio, Goddard decided to invent a machine that would voyage to the planet Mars. For the rest of his life, he was to commemorate that October day as his anniversary day, the birthday of his great dream. By the 1920s, after years of studying physics and engineering, he was experimenting with liquid fuel rockets. In order to build a rocket capable of reaching high altitudes, Goddard had to create the principles of an entirely new technology. He invented the basic components that propel, stabilize, and guide the modern rocket. It was painstaking and difficult work, but Goddard took the many setbacks in stride. He sifted the wreckage of each experiment for clues to guide the next. Constantly refining old techniques and inventing new ones, he gradually raised the rocket from a dangerous toy and set it on its way to becoming an interplanetary vehicle. Goddard died in 1945, before a rocket had ever left the planet Earth. Although Mars always remained his objective, Goddard knew that such a goal would be ridiculed. In public, he advocated only the more modest objective of flying to the moon. Those boyhood dreams of voyages to the moon and Mars, shared by Goddard with his contemporary, a Russian scientist named Konstantin Tsiolkovsky, were fulfilled only a few decades after their deaths. But, as it turned out, the first planet to be explored by rocket was the Earth. Now, imagine yourself a visitor from some other and quite alien planet. You approach the Earth with no preconceptions. Is the place inhabited? At what point can you decide? When we look at the whole Earth, there are no signs of life. We must examine it more closely. If there are intelligent beings, maybe they create engineering structures which can be seen at a resolution of a few kilometers. Yet, at this level of detail, even a great river valley seems utterly lifeless. There's no sign of life, intelligent or otherwise, in Washington, D.C., or Moscow, or Tokyo, or Peking. If there are intelligent beings on Earth, they have not much modified the landscape into regular geometrical patterns at kilometer resolution. But when we improve the resolution tenfold, when we begin to see detail as small as 100 meters across, the size of a football field, the situation changes. Many places on Earth seem suddenly to crystallize out, revealing an intricate pattern of straight lines, squares, rectangles, and circles. Canals, roads, circular irrigation patterns all suggest intelligent life with a passion for Euclidean geometry and territoriality. On this scale, intelligent life can be discerned in Boston and Washington and New York. At 10-meter resolution, we also discover that the Earthlings like to build up. At twilight or night, other things are visible. Oil well fires in the Persian Gulf, or the bright lights of large cities. And at meter resolution, we make out individual organisms, seals on ice floes, or people on skis. Intelligent life on Earth first reveals itself through the geometric regularity of its constructions. If Lowell's canal network really existed, the conclusion that intelligent beings inhabit that planet might also be compelling. But there is no canal network. Our unmanned spacecraft have examined Mars with 1,000 times more detail than any fleeting glimpse available through Percival Lowell's telescope. There is no question that his Martian canals were of intelligent origin. The only question was which side of the telescope the intelligence was on. Where we have strong emotions, we're liable to fool ourselves. Yet, even without the canals, the exploration of Mars evokes the kind of rapture that Columbus or Marco Polo must have felt. We see many impact craters, but we find no canals, none at all. There are fault lines in the surface and complex patterns of ridges and valleys, but they're all far too small and in the wrong places to be Lowell's canals, and they don't seem to be manufactured. There are many signs of water. Ancient river valleys wind their way among the craters. Nergal Valley, named after the Babylonian war god, is 1,000 kilometers long and 1 billion years old. There seems to have been a time when Mars was much warmer and wetter than it is today. I wonder if life ever arose in the muddy backwaters of these great river systems. The waters flowed at the same time that the great volcanoes of the Tharsis Plateau were made, before the present continents of Earth were formed. It was a very lively epoch on Mars. Equally old is the Mariner Valley, a strange, vast, mist-filled chasm. If it were on Earth, it would stretch from New York to Los Angeles. Landslides and avalanches are slowly eroding its walls, which collapse to the floor of the valley. There, the winds remove the particles and create immense sand dune fields. Signs of high winds are all over Mars. Often craters have, trailing behind them, long streaks of brighter dark material blown out by the winds, natural weather vanes on the Martian surface. For the sand to be blown about in the thin Martian atmosphere, the winds have to be very fast, sometimes approaching half the speed of sound. But some of the patterns are so odd and intricate that we cannot be sure they're caused by wind-blown sand. And there are other strange markings. Furrowed ground, almost resembling a giant plowed field 1 billion years old. And one of the strangest features on Mars, the pyramids of Elysium, 10 times taller than the pyramids of Egypt. Perhaps they're only mountains sculpted by the fierce winds, but perhaps there's something else. How marvelous it would be to glide over the surface of Mars, to fly over Olympus Mons, the largest known volcano in the solar system. The surface area of Mars is exactly as large as the land area of the Earth. It will be a long time before this planet is thoroughly explored. The only canal of Percival Lowell that corresponds to anything real is Mariner Valley. 5,000 kilometers long. It's a little hard to miss even from Earth. The Grand Canyon of Arizona would fit into one of its minor tributaries. Someday, we will careen through the corridors of the Valley of the Mariners. To skim over the sand dunes of Mars is, as yet, only a dream. But we have, in fact, sent robot emissaries to Mars. Their names are Viking 1 and Viking 2. The problem was where to land them. We knew that the volcanoes of Tharsis were too high. The thin Martian atmosphere would not there support our descent parachute. The great Mariner Valley was too rough and unpredictable. The polar caps were too cold for the lander's nuclear power plant to keep it warm. There were fascinating places that were too high, or too windy, or too hard, or too soft, or too rough, or too cold. We worried about the safety of every landing site. Perhaps we were too cautious. Eventually, we selected two places. One, optimistically named Utopia, for Viking 2, and another, 8,000 kilometers away, not far from the confluence of 4 great channels, a landing site for Viking 1 called Chryse, Greek for the land of gold. And so, after a voyage of 100 million kilometers, on July 20th, 1976, Viking 1 landed right on target in the Chryse Plain. It was less than 80 years since Robert Goddard had his epiphanal vision in a cherry tree in Massachusetts. After hibernating for a year during its interplanetary passage, Viking reawakened on another world. The first thing it did was to call home, reporting a safe arrival. It began to rouse itself according to instructions memorized months earlier. First, it put out a finger to test the Martian winds. Then, flexing its arm, it flung off a protective glove. Next, Viking prepared to sniff the air and taste the soil. Finally, it opened its eyes for a look at its new surroundings. Viking's first picture assignment was to photograph its own foot. In case Viking were to sink into Martian quicksand, we wanted to know about it before it disappeared. Back on Earth, we waited breathlessly for the first images. Viking painted its picture in vertical strokes, line by line, until with enormous relief we saw the footpad securely planted in the Martian soil. This was the first image ever returned from the surface of Mars. The cameras on each Viking lander revealed a kind of rocky desert. Beyond the lander itself, we saw for the first time the landscape of the Red Planet. It didn't look like an alien world. There were rocks and sand dunes and gently rolling hills as natural and familiar as any landscape on Earth. Forever after, Mars would be a place. We found that the Martian air was less than 1% as dense as ours and made mostly of carbon dioxide. There were smaller amounts of nitrogen, argon, water vapor, and oxygen. And there was almost no ozone, so the surface was not protected from the sun's ultraviolet light, as it is on Earth. On the warmest days, it was distinctly chilly. And every night, the temperatures plunged to 100 below. In winter, the surface was dusted with a thin layer of frost. The landing sites were chosen because they were safe and flat. Even so, Viking revolutionized our knowledge of this rusty world. I would, of course, have been surprised to see a grizzled prospector emerge from behind a dune, leading his mule, yet the idea seemed strangely appropriate. But at least while we were watching, no prospector wandered by. We studied with exceptional care every picture the cameras radioed back, but there was no hint of the canals of Barsoom, no sultry princesses, no 10-foot-tall green fighting men, no thoats, no footprints, not even a cactus or a kangaroo rat. Perhaps there was life inside the rocks or under the ground. If so, it had left no traces. For most of its history, the Earth had microbes, but no living things big enough to see. Perhaps the same is true for Mars. The Viking lander is a superbly instrumented and designed machine. It extends human capabilities to other and alien landscapes. By some standards, it's about as smart as a grasshopper. By others, only as intelligent as a bacterium. There's nothing demeaning in these comparisons. It took nature hundreds of millions of years to evolve a bacterium and billions of years to make a grasshopper. With only a little experience in this sort of business, we're getting pretty good at it. In both landing sites, in Chryse and Utopia, we've begun to dig the sands of Mars. On a very small scale, such trenches are the first human engineering works on another world. The robot arm retrieves soil samples and deposits them into several sifters. Then, the soil is carried to 5 experiments, 2 on the chemistry of the soil and 3 to look for microbial life. The Viking biology experiments represent a pioneering first effort in the search for life on another world. The results are tantalizing, annoying, provocative, stimulating, and deeply ambiguous. By criteria established before launch, 2 of the 3 Viking microbiology experiments seem to have yielded positive results. First, when Martian soil samples are mixed together with an organic soup from Earth, something in the soil seems to have broken the food down, almost as if there were little Martian microbes which metabolized, enjoyed the soup from Earth. Second, when gases from Earth were mixed together with Martian soil, something seems to have chemically combined the gases with the soil, almost as if there were little Martian microbes capable of synthesizing organic matter from atmospheric gases. But the situation is complex. Mars is not the Earth. As the legacy of Percival Lowell reminds us, we are liable to be fooled. Perhaps the ultraviolet light from the sun strikes the Martian surface and makes some chemical which can oxidize foodstuffs. Perhaps there is some catalyst in the Martian soil which can combine atmospheric gases with the soil and make organic molecules. The red sands of Mars were excavated 7 times at the 2 different landing sites, as distant from each other as Boston is from Baghdad. Whatever was giving these results was probably all over Mars, but was it life or just the chemistry of the soil? Studies suggest that a kind of clay known to exist on Mars can serve as a catalyst to accelerate, in the absence of life, chemical reactions which resemble the activities of life. It may be that in the early history of the Earth, before life, there were little cycles, chemical cycles running in the soil, something like photosynthesis and respiration, which were then incorporated by biology once life arose. There may be life elsewhere than in the 2 small sites we examined, or perhaps there's life of a different sort all over Mars. Life is just a kind of chemistry, of sufficient complexity to permit reproduction and evolution. I wonder if we'll ever find a specimen of life based not on organic molecules, but on something else, something more exotic. The Viking experiments found that the Martian soil is not loaded with organic remains of once living creatures. Maybe the reactive chemistry of the surface has destroyed organic molecules based on carbon. Or maybe there's no life on Mars and all Viking found was a funny soil chemistry. Or maybe there's life, okay, but it's not based on organic chemistry as much as life is on Earth. Personally, I don't think that's a very likely possibility. I'm a carbon chauvinist. I freely admit it. Carbon is tremendously abundant in the cosmos, and it makes marvelously complex organic molecules that are terrifically good for life. I'm also a water chauvinist. It's an ideal solvent for organic molecules, and it stays liquid over a very wide range of temperatures. But sometimes I wonder, could my fondness for these materials have anything to do with the fact that I'm chiefly made up of them? Are we carbon and water based because these materials were abundant on the early Earth at the time of the origin of life? Might life elsewhere be based on different stuff? I'm a collection of organic molecules called Carl Sagan. You're a collection of almost identical molecules with a different collective label. But is that all? Is there nothing in here but molecules? Some people find that idea somehow demeaning to human dignity. But for myself, I find it elevating and exhilarating to discover that we live in a universe which permits the evolution of molecular machines as intricate and subtle as we. The essence of life is not so much the atoms and small molecules that go into us as the way, the ordering, the way those molecules are put together. Now, we sometimes read that the chemicals which make up a human body are worth, on the open market, only 97 cents or $10 or some number like that. And it's depressing to find our bodies valued at so little. But these estimates are for humans reduced to our simplest possible components. What is all this stuff in front of me? These are exactly the atoms that make up the human body, and in the right proportions too. We're made mostly of water, and that costs almost nothing. The carbon is counted as coal. The calcium in our bones is chalk. The nitrogen in our proteins is liquid air. The iron in our blood is rusty nails, some phosphorus and some trace elements. If we didn't know better, we might be tempted to take all these atoms and mix them together in a container, like this. And stir. We could stir all we want, and at the end of it, all we'd have is some boring mixture of atoms. How could we have expected anything else? The beauty of a living thing is not the atoms that go into it, but the way those atoms are put together. Information distilled over 4 billion years of biological evolution. Incidentally, all the organisms on the Earth are made essentially of that stuff. An eyedropper full of that liquid could be used to make a caterpillar or a petunia, if only we knew how to put the components together. All life on Earth is made from the same mixture of the same atoms. On another planet, the jars of life might be filled with very different atoms and small molecules, but I think the life forms on many worlds will consist, by and large, of the same atoms that are popular here, maybe even the same big molecules. So I don't believe we can rescue the idea of life on Mars by appealing to some exotic chemistry. Sometimes we hear about possible life forms in which silicon replaces carbon, or perhaps liquid ammonia replaces liquid water. But at Martian temperatures, there don't seem to be any plausible silicon-based molecules which might carry a genetic code. And ammonia is liquid only under higher pressures and lower temperatures. Someday in the distant future, we might have a collection of jars, each containing the elementary biochemistry of another world. I don't know if there'll be one labeled Mars, but if there is, I bet it will be full of organic molecules. But there's another way to search for life on Mars, to seek out the discoveries and delights which that heterogeneous environment promises us. One of the things that a grasshopper can do, but Viking can't, is move. We landed in the dull places on Mars. For all the solid scientific findings and tantalizing hints which Viking provided, we know that there are an enormous number of places on the planet far more interesting. What we need is a roving vehicle with advanced experiments in biology and organic chemistry, able to land in the safe but dull places and wander to the interesting places. This roving vehicle was developed by the Rensselaer Polytechnic Institute. It has a long list of dumb things it knows not to do. A Mars rover hasn't got time to ask whether it should attempt a steep slope. Radio waves traveling at the speed of light take about 20 minutes for the round trip to Earth. By the time it got an answer, it might be a heap of twisted metal at the bottom of a canyon. A rover has to think for itself. Imagine a rover with laser eyes like this one, but packed with sophisticated biological and chemical instruments, sampler arms, microscopes, and television cameras, wandering over the Martian landscape. It could drive to its own horizon every day, a distant feature it barely resolves at sunrise. It can be sniffing and tasting by nightfall. Billions of people could watch the unfolding adventure on their television sets as the rover explores the ancient river bottoms or cautiously approaches the enigmatic pyramids of Elysium. A new age of discovery would have begun. Most of the human species would witness the exploration of another world. Only 80 years ago, we could come no closer to Mars than straining to see a tiny, shimmering image through a telescope in Arizona. Now, our instruments have actually touched down on the planet. Viking is a legacy of H.G. Wells and Percival Lowell, Robert Goddard. Science is a collaborative enterprise spanning the generations. When it permits us to see the far side of some new horizon, we remember those who prepared the way, seeing for them also. On each lander, there is a microdot on which is written very small the names of 10,000 men and women responsible for Viking's splendid achievement. One of the names in this microdot belonged to a friend of mine, a remarkable microbiologist named Wolf Vishniak. He was the first person to build a machine to look for microbes on another world. His friends called it the wolf trap. It contained a liquid nutrient to which Martian soil would be added, and any microbes that liked the food would grow in that nutrient medium and cloud it. The wolf trap was selected to go with Viking to Mars, but NASA is especially vulnerable to budget cuts, and the wolf trap was removed as an economy measure. It was a terrible blow to Vishniak. He'd worked 12 years on it. Others might have stalked off the project, but Vishniak was a gentle and dedicated man. He decided instead to study the most Mars-like environment on this planet, the dry valleys of Antarctica, which were long thought to be lifeless. But Vishniac believed that if he could find microbes growing in these arid polar wastes, the chances of life on Mars would improve. So in November 1973, Vishniac was left in a remote valley in the Asgard Mountains of Antarctica. He set up hundreds of little sample collectors, simple versions of the Viking microbiology experiments. On December 10th, he left camp to retrieve some samples and never returned. He had wandered to an unexplored area, apparently slipped on the ice, and fell more than 100 meters. Maybe something had caught his eye, a likely habitat for microbes or a patch of green where none should be. The last entry in his notebook was Station 202 retrieved, 22:30 hours. Soil temperature, minus 10 degrees. Air temperature, minus 16 degrees. It had been a typical summer temperature for Mars. Some of his soil samples were later returned, and Vishniac's colleagues discovered that there really is life in the dry valleys of Antarctica, that life is even more tenacious than we had imagined. That fact may turn out to be very important for the future history of Mars. There will be a time when Mars is thoroughly explored. What then? What should we do with Mars? If there is life on Mars, then I believe we should do nothing to disturb that life. Mars, then, belongs to the Martians, even if they are microbes. But suppose that Mars is in fact lifeless. Might we, in some sense, be able to live there, to somehow make Mars habitable like the Earth, to terraform another world? As lovely a world as Mars is, it poses certain problems for us. There's too little oxygen, no liquid water, and too much ultraviolet light. But all that could be solved if we could make more air. With higher atmospheric pressures, liquid water would become possible. With more oxygen, we might be able to breathe the atmosphere, and ozone could form to shield the surface from the solar ultraviolet light. The evidence for past liquid water suggests that Mars once had a denser atmosphere, which can't have all escaped to space. It has to be on the planet somewhere. In subsurface ice, surely, but most excessively in the present polar caps. To vaporize the ice caps, we must heat them, preferably by covering them with something dark to absorb more sunlight. That thing ought also to be cheap and able to make copies of itself. Well, there are such things. We call them plants. We would need to evolve by artificial selection and genetic engineering dark plants able to survive the severe Martian environment. Such plants could be seeded on the vast expanse of the Martian polar ice caps, taking root, spreading, giving off oxygen, darkening the surface, melting the ice, and releasing the ancient Martian atmosphere from its long captivity. We might even imagine a kind of Martian Johnny Appleseed, robot or human, roaming the frozen polar wastes in an endeavor which benefits only the generations to come. It might take hundreds or thousands of years. We might then want to carry the liberated water from the melting polar ice caps to the warmer equatorial regions. And there's a way to do it. We would build canals. But that's exactly what Percival Lowell believed was in fact happening on Mars in his time. The idea of a canal network built by Martians may turn out to be a kind of premonition. Because if the planet ever is terraformed, it'll be done by human beings whose permanent residence and planetary affiliation is Mars. The Martians will be us. Mars today is strictly relevant to the global environment of the Earth. Its antiseptic surface is a cautionary tale of what happens if you don't have an ozone layer. Its great dust storms and the resulting cooling of its surface played a role in the discovery of nuclear winter, the catastrophic climate change on Earth predicted to follow nuclear war. So if you didn't have an ounce of adventuresome spirit in you, it would still make sense to support the exploration of Mars. In recent years, there's been a groundswell of interest in organizing the first expedition of humans to go to the planet Mars. We first need more robotic missions, including rovers, balloons, and return sample missions, and more experience in long-duration spaceflight. But eventually, if all goes well, the interplanetary ship or ships would be constructed in Earth orbit, launched on the long journey to Mars, and then a landing module would set down on the surface. The crew would emerge, making the first human footfalls on another planet. It would be very expensive, of course, although cheaper if many nations share the cost. The key issue in my mind is whether the unmet needs down here on Earth should take priority. But that's a question even more appropriately addressed to the military budgets. Now, $1 trillion a year worldwide. You can buy a lot for that. Justifications for the Mars endeavor have been offered in terms of scientific exploration, developing technology, international cooperation, education, the environment. Some see it as the obvious response to the future calling. Some even think we should go to investigate enigmatic landforms, including one that resembles an enormous human face. Personally, I think this, like hundreds of other blocky mesas there, is sculpted by the high-speed winds, but if we're going anyway, there's no harm in taking a look. A remarkably diverse group of American leaders has endorsed the Mars goal. I imagine the emissaries from Earth, citizens of many nations, wandering down an ancient river valley on Mars, trying to understand how a quite Earth-like world was converted into a permanent ice age, and looking for signs of ancient life along the riverbanks. In the long run, the significance of such a mission is nothing less than the conversion of humanity into a multi-planet species.